So the following problem says, find the volume of the solid generated by revolving the region bounded by the given lines and curves about the x-axis using these sections. So they are already telling us which method to use, which is the disk method. I'm gonna write over here what is the formula one more time. From a to b of pi times the function of the radius squared dx. If it is in terms of y, then it is from c to t, and the function in terms of y, differential y. Now, I'm gonna start with the problem number 6, and I'm gonna write the equations, which is y equals square root of x. The lines, sorry. Y equals 0, x equals 0, and x equals 8. So what I'd like to do is, of course, try to graph it, so I have an idea of what I'm dealing with, and I'm going to use different colors for each equation. So first, let's graph y equals square root of x, so it's going to look something like this. And let me write it, y equal the square root of x. Now, another color, let's go with the next one. Y equals 0 is going to be an horizontal line. Okay, so y equals 0. X equals 0 is a vertical line. So I'm going to write x equals 0. And finally, x equals 8 is also a vertical line, in this case at 8. Okay. So what we want to do now is this area bounded by these curves, we want to rotate it over the x-axis. Okay, so let me erase this real quick. This area I'm going to rotate over the x-axis, and what is the equation of my radius? Is going to be the distance between the x-axis to the parabola, in this case y equals the square root of x. Now this is going to look something like this when I finish rotating it, and let me finish the counterpart of this. Well, it should be touching it, so something like this. Okay, it's gonna be kind of like a cone. Now we have all the components. We know that x equals 0 and x equal 8 are our bounds, and the radius is once again the function of the parabola. So I'm gonna plug it into our equation. It's gonna be, the volume is gonna be the integral from 0 to 8 of pi that multiplies the function of the radius. In this case, it's gonna be square root of x squared dx. I can take the pi out since it is a constant, and when I square the square root, it goes away, and I have the integral from 0 to 8 of x dx. We're almost done, and we have now pi. The antiderivative of x is x squared over 2, and I'm gonna evaluate it at my upper and lower bound. However, my lower bound is 0, so when I plug it in, it's just going to go away. And now it's gonna be pi that multiplies, in this case, 8 squared over 2. However, 8 squared is 64, and 64 over 2 is 32. Therefore, our final answer is 32 pi. Therefore, the correct option is going to be option C. Okay, let's go with the next one. Now, problem number 7. It says my lines are y equal x, y equals 0, x equal 2, and x equal 4. Okay, so one more time, I will draw my Cartesian plane, and I'm gonna start drawing my lines. So the first one, it says the function y equal x, so it's gonna look something like this. Actually, let me draw this way. Better, let's say it crosses the origin. The next one is y equals 0. Remember, this is just representative. Well, let me label it first. This is y equal x. it doesn't have to be perfect, just so you guys have an idea of what you're dealing with or how does it look like. Y equals 0. The next one is x equal 2. Draw it green. My bad. Draw a line. Okay, this is my line x equal 2. And finally my line x equal 4, which I'm gonna do purple. Okay. Once again, the area that I'm gonna be revolving is this one. And I'm gonna revolve it over the x-axis. So I'm gonna draw the axis of rotation. And the circle is gonna look something like this. In this case, the function of my radius is going to be the line y equal x, and we already have that our bounds are x equal 2 and x equal 4, 2 and 4 respectively, lower and upper. So let's plug it into our formula. So we have that the volume using the disk method is going to be the integral from 2 to 4 of pi that multiplies the function of the radius, which we already said is y equal x. So it's going to be x squared dx. Now we can take the pi out because it's a constant, and this is going to be integral from 2 to 4 of x squared dx. Now the antiderivative of x squared is x to the cube over 3, and we're going to evaluate that at 4 and 2. Okay, so I'm gonna continue over here, and I know that this is gonna be pi that multiplies 4 to the cube over 3 minus 2 to the cube over 3. So get your calculator and do the equation. In this case, it's just gonna be 4 to the cube minus 2 to the cube. It's gonna be 56 over 3. And it's gonna be 56 over 3 pi, which is your final answer, and therefore the correct option is gonna be option C once again. Okay. For problem 8, we have y equal x squared, we have y equals 0, and we also have x equals 0 and x equals 4. Okay, now once again, let me draw my Cartesian plane. Doesn't has to be perfect. Now I will start drawing my lines. So the first line is the parabola y equal x squared. The next one is the line y equals 0. The next one is the line x equals 0. And the last one is line x equals 4. Which I'm gonna do pink, it doesn't matter. I'm gonna do it over here. Okay, pink is x equals 4. And the area contained these graphs is gonna be the one you see in black. And the radius of this is going to be the parabola y equal x squared. So if I draw a line between the x-axis to the parabola, I can just rotate this, and it's gonna look something like this. Oh boy, let me do it more narrow, something like that. So the corner part is gonna look something like this. Okay, it's gonna be kind of like a cone one more time. So now that we have all our components, remember our bounds is gonna be from 0 to 4, and our function is already in terms of x, and we're revolving over the x-axis, so just plug in. So b is gonna be the integral from 0 to 4 of pi that multiplies the radius squared. This case is gonna be the function of the parabola, so it's gonna be x squared squared dx, which at the end is going to be just x to the fourth. We can take the pi out because it's a constant. I should start writing the pi already outside. 0 to 4 x to the 4 dx. Now this is going to be equal to what? Well, the antiderivative of x to the 4 is x to the 5 over 5 plus the constant c. But since it is definite, we do not care about that. So it's going to be x to the 5 over 5. And we evaluate this at 4 and 0. Now this point, when we plug in the 0, it will not count towards our final result. So we just care about the 4. So it's going to be pi. And it's going to be 4 to the 5th over 5. Which at the end is going to be just, let me do real quick, 1024 over 5 pi. Which is our final answer. Therefore, the correct option is going to be option A. I hope you all guys found this video useful. If you did, well, subscribe to the channel, hit the like button, leave me in the comments what would you like to see next, and I hope to see you all in the next episode. Have fun!